Hello, my name is Guy Hunt, and I am one of the developers of the Latent Cluster ALS Webserver, which you should be able to see presented here before you. And I'm just going to give you a quick tutorial on how to use the Webserver. So to start off, when you land on when you open up the website, you'll be faced with a tutorial video, which will be this video, and then you'll be given an example phenotypic file. So I'm just going to open that up, and I'm going to walk you through it. So, getting the phenotypic file right in the correct format is crucial for the Webserver to work. So I'm just going to highlight the columns that you need to include. I'm going to walk you through each of these. So first of all, just to make sure we're all on the same page, each row here relates to a separate individual who's been diagnosed with ALS. And the data contained in this phenotypic file is completely made up. So it doesn't relate to any real patients, but it's just useful for testing the website. So the first column that we need is country of diagnosis, which is the country at which this particular patient, so patient number 1, was diagnosed. And we need this in the form of ISO alpha 2 codes, so 2-digit country codes. The next column is diagnostic delay. So this is in years. We need the diagnostic delay in years, so the time from symptom onset until diagnosis. And then there are a number of categorical columns here. So we've got sex at birth, and it has a 2 and a 1. So if you ever need to check up on which way round the 2 and the 1 go to, if you go onto the README file, you can see sex at birth, 1 equals male, 2 equals female. Then for site of onset, the next one, we've got 0 equals non-bulbar onset, 1 equals bulbar onset. Then age of onset in years, which is the age of onset of symptoms in years. Time to death or last follow-up is the number of years between symptom onset to death or censorship. And we have these more categorical columns here, so phenotype 1, phenotype 2, phenotype 3. And then if we flick back onto the README, phenotype 1 is if they've been clinically diagnosed with ALS, so 0 is no, 1 is ALS. Phenotype 2 is diagnosed with PLS, so 1 is PLS, 0 is other. And clinical phenotype 3 is diagnosed with PMA as 1 and other as 0. And then you are free to include whatever additional columns that you want to in this. They won't be used as part of the clustering, but you can use them in some phenotypic comparisons of the clusters later on. So I will close down this, but I just wanted to explain this and how all of the data works, because the number one error that we receive on the web server will be people putting in slightly different formatted columns, whether they include spaces here, they don't include all the columns, etc. So if you're having an issue with the web server, the first thing to check is that your columns match up to the ones in this phenotypic file that you can download from the web server. So I'll close this. I do not want to save. So back onto the tutorial page. So after you've downloaded the phenotypic example file, then you can go onto the phenotypic clustering tab here, and you simply upload the file. And I'll go on to the downloads just to prove the one I've just downloaded. And at this point, you can select 3 different machine learning models that are available. The first one is based on data that's available at first visit. So if you don't have disease duration, that's the one column that's okay not to have, but you will have to use the machine learning model that was developed without disease duration. Equally, if you have all uncensored patients, so if they've all sadly died, you can use the uncensored patients data machine learning model. Or if you've got a mix of censored and uncensored patients, then you can use the mixed model. So without further ado, I'll just treat this as the first visit one, and I will perform the clustering. And you'll see that when the widget stops, the analysis is complete, and you will be presented with linear discriminant analysis. So here we can see all 5 of our different clusters in our linear discriminant analysis. So we can hover over and see some phenotypic information. And the column that we display, you can change here. So if I just change it to, let's go for neurofilament level. It'll refresh and tell you the neurofilament level. And you can see for each of the clusters here, they're colored differently, and you can see how well they're separated. You can download this plot if you so wish. You can see all of the plots on the web server are like this, where you can download a good quality image of them. You can also explore them as you so wish. Below is a full table of the clustering results. So one of the things that will have been updated is the diagnostic delay will have been scaled towards the country of diagnosis, where possible. And then there will be a few other columns that will be added. So you'll have a column here which will indicate the cluster that the individual has been assigned to. And then you'll have the standardized age of onset, the standardized diagnostic delay that doesn't take into account country code. So we don't really use this. And you've got the standardized time to death. And then you'll also have the linear discriminant 1, 2, 3, 4 values for each of your patients. And if you scroll to the bottom, you can download this as a CSV. So after you've got the clusters, you can do some phenotypic comparisons. So what you've got here is you can select a continuous variable which you want to compare between the clusters. So this has to be something that's a large numerical number that varies fairly significantly, such as age of onset you could do, but I'm going to include one of the additional columns I included in the phenotypic file, the neurofilament level. And then you can also select a number of categorical variables that you want to include as cofactors. So here I'll do sex at birth and site of onset. Then when you perform the analysis, you'll be presented with a box plot. So you've got each of the different cluster assignments at the bottom, and you can see the neurofilament level here. And then at the bottom, or so in the summary statistics, you can see the number of individuals you've got in each cluster, the mean neurofilament level, the standard deviation, median, etc. Then you can also see that we've done comparisons between each of the different clusters. So this is a comparison between cluster 2 and cluster 1. You can see the difference in neurofilament level, the lower confidence interval, the upper confidence interval, and the adjusted p-value. So this allows you to test if there are differences in continuous variables between your clusters. So this could be anything from certain gene expression values through to biomarkers, etc., for each of the patients. And you can download both the summary stats table and the comparison table and review the information in a nice CSV. So finally, I'll go back onto the README, which is what I displayed earlier, which contains all the information that you need to include in the phenotypic file. And just here are all of our contact details. If you face any technical issues with the website, such as error messages which you can't fix, please contact me. I am Guy Hunt, this one here. For anything else regarding how the clustering was created or anything about the paper, please contact Tom Spargo and Alfredo. That kind of brings up a wrap for the tutorial. So I hope you have fun using the website, and please get in touch if you need any help.